So this is lecture 21, and today is 26th of February. So let's see where we are again. We are talking about discussing trusses. And as we discussed last time, there are two objectives when in dealing with truss problems. One is that if in two cases, case one, that we want to find all member forces, which typically we use the method of joints, or we want to find only a few member forces, that we will use method of sections, which we haven't discussed yet. So we will continue with this. The procedure that I introduced was very simple. Okay. You start by setting up XY coordinate system. Okay. And two, identify zero force members. And then, okay, start with a joint that has least number of unknowns. Okay. You draw the free body diagram, solve for those unknowns, move to the next joint with the minimum number of unknowns until you're done. You always end up, again, similar to frames, with one free body diagram that you haven't used. You can use that to verify your answers. And as you notice, of course, intentionally, I never mentioned that you have to find the external reaction forces first. You don't have to. You don't have to. The general procedure is that you start with minimum number of unknowns, a joint with minimum number of unknowns. All right. Any questions? Let me admit him. I'm not sure what we can do to make sure everybody comes on time and doesn't waste people's time. Okay. So I'm going to finish the problem that I had started last time. We did a good part, part of that. This was the problem. Okay. Okay. This was 6 meters. So we had all these members that, of course, as we, solved the problem last time, let me label these. We had a force of 20 kilonewton. So as we demonstrated, we ended up with only these members. This one, A, B, C, D, this one, this member, F, this member, okay, H, and I had a force of 30 kilonewton here, and then this member, okay? So, and of course, this member. So the truss was reduced to finding basically 1, 2, 3, 4, 5, 6 members, right? Instead of 1, 2, 3, 4, 5, 11 members, right? Okay, 12 members. So, and these, of course, dimensions are given. All right, so we solve for most of the unknowns. F of AH, which is this one, came out to be 33.3 kilonewton compression. Force in AB, So I'm going to just write those down, which is this one, or this member was 26.7 tension. Force in HD, which is this member, we've calculated that. It was 18.2 kilonewton compression. And then force of HF, which is this one, we did that, came out to be 58.5 kilonewton, and that was compression. And I hope that you did not just accept these from me and you went out and confirmed these were right answers. If not, well, we're going to continue with that assumption. All right. So let's see. We have found this member force, this one, okay, this one, and this one. So we have only these two members left. Now, you go to a joint with minimum number of unknowns. Here we have 1, 2. Here we have 1, 2, 3. So I'm going to choose this one. All right. And if I solve for these two unknowns, basically this member force is that reaction force. So I have found that one too. So let's go with joint D. I have the force from AB, which is a tensile force. That means the force is moving away from this joint, and that is 26.7. Force in DE, which I'm trying to find, and the force in this member DF, which is unknown. Okay, and I just assume it is in that direction. And then this force, which is force of DH, I had found, and it was DH was also compressive, so coming toward the joint. So this is that force, 18.2. And the slopes here, we had found those. This is 2, 3 square root 13. For this one is 2 and 6, so is 1, 3 square root 10. So now I want to find these two unknowns, right? Obviously, of course, you resolve these into their components. Okay. So this is 3 over square root 10, okay, of f df. This is 1 over square root 10 f df. This one is 2 over square root 13 times 18.2. And this one is, oh, I'm sorry, this one is 3. This one is 2 over square root 13, 18.2. Okay, so since I have two unknowns, if I project them along x-axis, whereas only one along y-axis, I start with summation of force along y is equal to 0. So I have this one, 18.2 times 3 over square root 13 plus 1 over square root 10, this unknown force F dF, okay? And that's it, is equal to 0, okay? Oh, no, I'm sorry, I have this one too. I have this one, and I wrote both of them, right? So that's all I have, okay? So if you solve for that, for this force, dF, you end up with f of dF, okay? Let me double check that here, okay? So if you solve for this, you see that f of d df, okay, comes out to be 47.9 negative, okay? That negative sign means what? That the assumed direction here is wrong. So I have to change that. So this is the correct direction. So the force is moving away from the joint. That means this is in what? Tension. And that's the value. Okay. So that was a kilonewton or kilonewton. Okay. Now I have summation of forces along x equal to 0. That would give me negative 26.7 negative f of d e plus this one, which is plus 2 over square root 13 times 18.2, and this one plus 3 over square root 10 times 47.9 is equal to 0. Okay, so if you write all of those, okay, you can see that f of dE, okay, comes out, which is this one, to be positive 29.3 kilonewton. And obviously this force is moving, coming towards the joint, so the corresponding member is in compression. So we solve for this and this now. So all member forces have been found. If you want to confirm or verify if your answers are right, as I promised, you always end up with one free body diagram that you had not used. And what is that? You haven't used this joint free body diagram, but that obviously requires that you find these unknowns, which you could have found them by looking at the free body diagram, the whole structure. In other words, if you take summation of moments about F is equal to 0, that would have given you this reaction force, which is the same as this one, okay, R at E. And then by writing summation of forces along X, 0, summation of forces along Y is equal to 0, you could find Fx and Fy, okay? So now if you have these, you look at this free body diagram that you had not used, free body diagram of this joint. And these answers you found, which is for HF and DF, right, should satisfy the equilibrium. Should satisfy basically summation of forces along X and Y 0. So that would confirm if you have correct answers. Any questions?
So do we need to solve for the Fy and Fx, or is that like, are you saying that that's like extra
You
information?
don't have to. If you just want to verify the answers that you have found are correct, you need to use a free body diagram that you haven't used.
Okay.
And what you have for which is this one.
Okay.
But if you want to use that one, then you need to find these. Okay.
And then also, is the FAB supposed to be in kilonewtons?
FAB, AB is, yeah, I didn't put it here. No. Yes. All of them are kilonewtons.
Okay.
Yeah. Any other questions? All right. So let me do another problem. Okay. And that is a problem which I have, in fact, selected from your book. It's a homework problem, but that's okay. So be it. All right. So let me do that. Okay. So we found, let me make sure, we did find all the forces here, right? Okay, AH, right. All right, okay. So let me do this problem, okay? You have, this is problem 6.28 from your book. It's a good problem, so that's why I am, choosing this one to do, okay? So you have a truss that looks like this. 1, 2, 3. Then you have, so we have, okay. So let me draw that first. This is 15 kips, and you probably don't remember, but kips means 1,000 pounds, meaningless unit. Okay. So let me label this A, B, C, D, E, F, G, H. So this is, the height is 15 feet, and these are each 12 feet. So we have a truss loaded. It looks like a crane structure. You're lifting a heavy load, and which means you have only one load acting at that joint, and the problem is asking you to find all unknown member forces. So step 1, set up your X, Y coordinate system. Step 2, what is a step 2? Does anybody remember? Anybody?
Identify zero force members.
Yes, 0 force members. Okay. And what is that? You look at a joint which has 3 or fewer forces. The reason I say fewer, and I may kind of sidetrack here, but that's important. Let's say, for instance, there was no load here, but you had a load here. Okay. So at this joint D, I have only 2 members. What happens there? Can anybody tell me if, let's say, that joint had no load, had only 2 forces coming to it? What happens? How do I find these 2? Or can you quickly tell me how much is the value, how much is the force in each of these members? Use the concept of 0 force members. That's a hint. I'll give you 10 seconds and counting.
Well, doesn't the y component of the force HD have to be 0 because the sum of all the forces in the y direction are 0?
You're getting there.
And then the x components of CD and then HD have to be the same but opposite?
Okay. So what happens?
They cancel out.
So that means, go on.
I'm not too sure where to go from
That's
there.
okay. That's okay. Look at the free body diagram here. If you had a force here and you had a force here, that's what the free body diagram of this joint would be. What happens? If you write summation of forces along y0, this is the only force that has a y component, right? So that would be 0, right? If that is 0, that means you only have forces along x, and that has to be 0, right? That means both of these have to be 0. So we conclude a special case of what I have told you about identifying the zero force members. I said that if you have three forces at a joint, two are collinear, the third one is zero, right? So if you don't see this immediately, think of this joint, presumably that there was another member here. So these two are collinear. So this would have been then zero, right? So if this is zero for that reason, and this is just fictitious, this is zero, doesn't exist, I just added that, right? So if this is zero, this has to be zero. So what do we conclude? A special case. If you have a truss with a joint where that joint does not have an external load and only two members coming to that joint, both of those members are zero force members. Remember that. This is a concept which is very important, and I've given many example problem, exam problems trying to help you to remember that concept. So we don't have that here. Let's go on. Let's go on with identifying the zero force members given this loading. So in this truss, if the loading was here instead of here, these two would be zero. Okay, remember that. All right, so let's go with joints with three forces coming together and two are collinear. The first one comes to my attention is H. Two collinear, only three forces. This one goes. Once that is gone, you look at C. 1, 2, 3, two collinear. So this is gonna go. Once that is gone, you look at G. 1, 2, 3, only two collinear. This will go. Once that is gone, look again. Only 1, 2, 3, two collinear. So this is gonna go. So this truss that originally had 13 members to solve for is reduced to what? 1, okay, 2, 3, 4, 5 members only. Doesn't it make your life easier? If you had not detected those zero force members, imagine what a pain you have to go through. Okay? So once you've done that, now I'm gonna go with what? Start a joint with minimum number of unknowns. Okay? And what would that be? Look, 1, 2 unknown here, 1, 2, 3 here, 1, 2, 3, 4 here, 1, 2, 3, 4 here. So obviously I'm going to start with D. So let's go to D. Draw the free body diagram of that joint. You have, let's say, F of AD is acting this way, and you have also a force of FD that acts that way, and you have the applied load of 15 kips. So this is the free body diagram. We have the slope of this line. It is 36, 15. So would be what? 12 of 5 and 13. So the slope of this line is 5, 12, 13. Okay? So let's try the equations of equilibrium. I will start with summation of forces along y is equal to 0 because that would involve only one unknown. Resolve this into its components. Okay? This component would be 5 over 13 FD, okay, positive, negative 15 equal to 0. So F of FD comes out to be positive 39 kips. Came out to be positive, that means the assumed direction is right. Force is going towards the joint, that means this is in compression, okay? Write summation of forces along X equal to 0. So you have this, which is 12 over 13 of 39, which is this force now, minus F AD is equal to 0. So F AD comes out to be 36 kips. So the assumed direction is right because this came out to be positive. Force moving away from the joint, that means this is in tension. Any questions before I go any further? So I found this one and I found this one, these two members. Because this is one member, this was one member, right? All those members disappeared. So look at a joint again with minimum number of unknowns. I still have 3 here, 1, 2, 3, 4 here, but only 2 here. So I would go to joint A. Force of AD, okay, is tensile. That means is acting this way, moving away from the joint. That is that force. I don't know what direction this force is, so I'll just put it like that. Force of AF. And I don't know what direction is this one. This is the force of AE. Okay. And the slope of this is going to be 15, 12, or 5, 4, square root of 41. Okay. So that's this free body diagram. So again, you obviously resolve this one into its components. Okay. So I write summation of forces along X equal to 0 here, because that involves only one unknown. And that would be this one, which is negative F AE times 4 over square root 41 plus 36 is equal to 0. Okay. That gives me F of AE comes out to be 57.6 kips. Okay. So force moving away from the joint, that means this is a tensile force. Okay. Now write summation of forces along Y is equal to 0. I have this one, which is negative 57.6 times 5 over square root 41 plus force of AF equal to 0. So force of AF comes out to be 45 kips. Force coming towards the joint, so the corresponding member is in compression. So I solve for this. I solve for this. How many unknown member forces I have left? This guy. So again, look at the joints. This joint has 1, 2 unknowns. This joint has 1, 2, 3 unknown. So I'm going to use this joint. Okay. So let's look at joint F. I have force of AF, which I have it here, is 45, compressive, so coming towards the joint. So this is 45 kips. I have this unknown force, assuming it is acting in this direction, force of EF. I have this force of FD. FD is 39 compressive force coming toward the joint then. Remember, this was 12, 5, 13. This is force of FD, which is 39. So this is 39 kips, okay? And then I have the reaction force, which is unknown. I don't care about that. I don't need that. I've been asked to find is the last member. So write summation of forces along X equal to 0. I have F of EF minus 5 over 13 times 39 is equal to 0. Okay, that will give me F of EF is equal to 36 kips. Force is coming towards the joint, so the corresponding member is again in compression. So I found all member forces, right? There's one joint you didn't use again, and that is this joint, okay? If you want to use that joint to verify your answers, you should have solved for these unknown external reaction forces. And if you have those, then you can use this free body diagram. Just for the fun of it, let's do that. If you use this free body diagram, you want to find external reaction forces. It's obvious this would be 0. I don't need even to solve for that because you don't have any force acting in the X direction on this structure. So you have these two unknowns. I take summation of moments at E is equal to 0 in order to find this guy, all right? So I have negative 15 times this distance, which is 48, plus RF times 12 is equal to 0, okay? So RF comes out to be 60 kilonewton, and then writing summation of forces along Y is equal to 0, okay? So I use this one, that one, equal to 0. What does that give me? That gives me EY plus 60, okay, minus 15 is equal to 0. That means EY comes out to be negative 45. That is, the assumed direction here is wrong. So this is EY, okay, kips. So I have these two unknowns. Let me use this joint to confirm the answers that I have got were correct. So let's use this free body diagram. Okay, so force of AE, which we had found here, is 57.6 tension. So this is a free body diagram of E. I have, this is 45, okay. This one I had EF is 36, which is compressive. So it's coming this way, okay. And then I have this force, AE, which was tensile. That is like this, okay. So you have 57.6, and the slope here was what? Was, okay, 5, 4 square root 41. So these numbers should satisfy both summation of X equal to 0 and summation of Y equal to 0. If so, the answers are correct. So let's use one of them. Let's use this one. I have negative 36 plus 56.7 times 4 over square root of 41. If you do the calculation, you see this is going to come out to be 0. So the answers that we found were correct. Any questions? No? All right, I'm going to do another problem. I have a very good problem also from your book, which I'm going to do that. Is a very interesting problem. 610. I was looking for a good problem, and I thought this would be good because it also helps me by introducing a simple yet very important concept. Okay. And what is that? Okay. This is a truss. Let me label those A, B, C. This is how your book labels these trusses. E, F, G, H. You have a support here and another support here. Okay. The truss is loaded at all upper joints like this. You have 600 pounds, 600 pounds, 600 pounds, 300 pounds, 300 pounds. And the problem is, and of course, these dimensions are given. Okay. 8 feet, 8 feet, 8 feet, 8 feet. And these are given 6 feet and 6 feet. The problem is asking you to find all member forces. Okay. I told you, of course, the procedure is that you start with setting up XY and then 0 force members. So let's complete those steps. Then I'm going to show you something very interesting. Do you see any 0 force members? Look at a joint with 3 forces, 2 collinear. So if you look at G, look at C, both satisfy those conditions. 3 forces, 2 collinear. So this one is gone. Same thing here. This one will go. And there is no other joint with only 3 forces and 2 collinear. Before you move to the next step, to start with a joint with minimum number of unknowns, let me tell you this. These are, again, important tips that I'm giving you that saves you time. Remember, 2 members coming together and no external load, both members are 0. That was the special case of 0 force member. That was the first tip today. The second tip is this. If you have a truss which has a line of symmetry, both loads and the structure are symmetric with respect to that line. You see, symmetry of the load, symmetry of the structure. Okay. 2 things happened. One, without any calculations, you do know that half of the load that is on the truss goes here, the other half goes here. So you can quickly write the value for these reaction support forces. This is 2,400. So this is 1,200 pounds, and this support carries 1,200 pounds. That's part number 1. Second, even more important, if you have this symmetry, load symmetric, structure symmetric with respect to this, with respect to the line of symmetry, all those members that are symmetric carry the same load. That is, this member and this member, the load in these 2 will be the same. Load in these 2 members with forces would be the same. Forces in these 2 members would be the same. Forces in these 2 members would be the same. So you don't have to use every single joint to find these unknown forces, okay? All you do is just basically do half the truss, and that's what I would do. Now I would start with a joint with minimum number of unknowns, and you can see that you have only 1, 2 here. Here you have 1, 2, 3. Here you have 1, 2, 3. So I would start with this. So I would write, any questions? This is very important. Very simple, yet very important. Okay. Recognize or detect the symmetry. Okay. So I will start with the free body diagram of disjoint. If you look at the geometry, you see this is going to be 3, 4, 5. So this is the force of AB, assume that direction, and force of AE. Okay, so let's use that free body diagram. If you just simply write summation of forces along y is equal to 0, you see you have negative 3/5 of FAB minus 300 plus 1200 equal to 0. And you find f of AB, that comes out to be 1,500 pounds. Force coming toward the joint, so this is a compressive force. You write summation of forces along x is equal to 0. You get f of AE minus this force component of this, which is 1,500 divided by 4/5 equal to 0. F of AE comes out to be 1,200 pounds. Force moving away from the joint, so this is tensile. So you have found this force member in this force in this member, as well as this one and this one, because AB, force in AB, is the same as force in FH, and force in AE is the same as the force in EH. Okay, move on. This joint now has 1, 2, this joint still 1, 2, 3, and this joint still 1, 2, 3 unknowns. So I'm going to go to this joint. So let's draw this free body diagram. This is the force of BD, which is of course the force of DF as well. This is the force we have found, which is 1,500. This is the force that we haven't found. Okay, this is force of BE. And then you have an applied load of 600 pounds. So this is the free body diagram of B. If you resolve again all these forces into their components, okay, and write equations of equilibrium, if you write summation of force along X, you have 1,500, this force, its component, this is, remember, this is 3, 4, 5. These are also 3, 4, 5, and this is 3, 4, 5. Okay, so X component would be 1,500 times 4/5 positive for this guy, and this guy would be negative. So you have negative 4/5 FBE and negative 4/5 FBD is equal to 0. So you can simplify this where you have F of BE plus F of BD is equal to 1,500. That's what results from summation of forces along X. Write summation of forces along Y is equal to 0. Okay, these components, you get 3/5 of 1500, this force, then plus 3/5 of FBE. For this one is negative, so negative 3/5 of FBD, and then you have negative 600 equal to 0. So you get FBE minus FBD, okay? This would be, okay, you need to multiply by 5/3. That's what I did. So this is 1,000. So you get negative 1,000 plus 1,500, you get negative 500. If you solve for these, you see that you get f of BD comes out to be 1,000 pound for BD, and would be correct direction. So would be compressive. For FBE comes out to be also 500, also correct direction 500. So you solve for this force, this one, and this one. So the only one left is this guy. So you can quickly write free body diagram of D. You have 600. You have, this is 1,000, as we found. This is 1,000 pound, slopes of 3, 4, 5, 3, 4, 5, and then let's assume this is upward, f of DE. If you write that, you get f of DE, okay, minus 600 plus 3/5 of 1,000, this one, plus 3/5 of 1,000, this one, equal to 0. You see f of DE comes out to be negative 600, means the assumed direction is wrong. So this force is actually acting this way. That means force moving away from the joint. So this guy is actually in tension. And you solve for all these forces. If you want, you can use one joint that you have not used, and that is this joint, to verify your answers. And I bet you if you do that, you see that the answers are going to be confirmed. Any questions? Okay. If not, have a terrific weekend, or those of you who are going to come to my office hours, I'll see you at 11:30. Have a good one.
Thank you.
You.
Thank you.
Hi, Professor. I'm not too sure if you received my email yesterday about homework set
Before I
7.
answer your question, let me see. I